Okay, so let's start with a new tutorial, that is generative AI in computer vision. Generative AI algorithms can be used to improve the efficiency and accuracy of existing AI systems, such as the natural language processing and computer vision. For example, a generative AI algorithm can be used to create synthetic data that can be used to train and evaluate other AI algorithms. Let's try to understand as to what is computer vision. Computer vision is a field of artificial intelligence that enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs and take actions for or make recommendations based on the information. Computer vision tasks include methods for acquiring, processing, analyzing, and understanding digital images and extraction of high-dimensional data from the real world in order to produce numerical or symbolic information, for example, in the forms of decisions. Computer vision works much the same way as human vision, except humans have a head start. Human sight has the advantage of lifetimes of context to train them how to tell objects apart, how far away they are, and whether they are moving and whether there is something wrong in an image. Computer vision trains machines to perform these functions, but it has to do it in much less time with cameras, data, and algorithms rather than retinas, optic nerves, and a visual cortex. Because a system trained to inspect products or watch a production assets can analyze thousands of products or processes in a minute, noticing imperceptible defects or issues. It can quickly surpass human capabilities. Computer vision is used in industries ranging from energy and utilities to manufacturing and automotive, and the market is continuing to grow. It is expected to reach $48.6 billion by 2023. How does computer vision work? Computer vision needs lots of data. It runs analysis of data over and over until it discerns distinctions and ultimately recognizes images. For example, to train a computer to recognize automobile tires, it needs to be fed vast quantities of images and tire-related items to learn the differences and recognize it, especially one and with no effects. Two essential technologies are used to accomplish this: a type of machine learning called deep learning and a convolutional neural network, that is CNN. Machine learning uses algorithms, models that enable a computer to teach itself about the context of visual data. If enough data is fed through the model, the computer will look at the data and teach itself to tell one image from another. Algorithms enable the machines to learn by itself rather than someone programming it or to recognize the image. A CNN helps a machine learning or deep learning model look by breaking images down into pixels that are given tags or labels. It uses the labels to perform convolutions, a mathematical operation on two functions, to produce a third function and make predictions about what it is seeing. The neural network thus runs convolutions and checks the accuracy of its predictions in a series of iterations until the predictions start to come true. It is then recognizing or seeing images in a way similar to humans. Much like a human making out of an image at a distance, a CNN first discerns hard edges and simple shapes, then fills in information as it runs iterations of its predictions. A CNN is used to understand single images. A recurrent neural network, that is RNN, is used in a similar way for video applications to help computers understand how pictures in a series of frames are related to one another. Computer vision application. There is a lot of research being done in computer vision field. It It is not just research. Real-world applications demonstrate how important computer vision is to endeavor in businesses, entertainment, transportation, healthcare, and everyday life. A key driver for the growth of these applications is the flood of visual information flowing from smartphones, security systems, traffic cameras, and other visual instrumented devices. This data could play a major role in operations across industries, but today goes unused. The information creates a test bed to train computer vision applications and a launch pad for them to become part of a range of human activities. IBM used computer vision to create My Moments in 2018 Masters Golf Tournament. IBM Watson watched hundreds of hours of Masters footage and could identify the sights and sounds of significant shots. It curated these key moments and delivered them to the fans as personalized highlight reels. Google Translate lets users point a smartphone camera at a sign in another language and almost immediately obtain a translation of sign in their preferred language. The development of self-driving vehicles relies on computer vision to make sense of the visual input from a car's cameras and other sensors. It's essentially to identify other cars, traffic signs, lane makers, pedestrians, bicycle, and all other visual information encountered on the road. IBM is applying computer vision technology with partners like Verizon to bring intelligent AI to the edge and to help automotive industries identify quality defects before a vehicle leaves the factory. Computer vision examples. Many organizations don't have the resources to fund computer vision labs and create deep learning models and neural networks. They may also lack the computing power required to process huge sets of visual data. Companies such as IBM are helping by offering computer vision software development services. These services deliver pre-built learning models available from the cloud and also ease demand on computing resources. Users connect to the services through an application programming interface and use them to develop computer vision applications. IBM has also introduced a computer vision platform that addresses both development and computing resources concerned. IBM Maximo Visual Inspection includes tools that enable subject matter experts to label, train, and deploy deep learning vision models without coding or deep learning expertise. The vision models can be deployed in local data centers, the cloud, and edge devices. While it's getting easier to obtain resources to develop computer vision applications, an important question to answer early on is what exactly will these applications do? Understanding and defining specific computer vision tasks can focus and validate projects and applications and make it easier to get started. Here are a few examples of established computer vision tasks. Image classification sees an image and can classify it, a dog, an apple, a person's face. More precisely, it is able to accurately predict that a given image belongs to a certain class. For example, a social media company might want to use it to automatically identify and segregate objectionable images uploaded by users. Object detection can use image classification to identify a certain class of image and then detect and tabulate their appearance in an image or video. Examples include detecting damages on an assembly line or identifying machinery that requires maintenance. Object tracking follows or tracks an object once it is detected. This task is often executed with images captured in sequence or a real-time video feeds. Autonomous vehicles, for example, need to not only classify and detect objects such as pedestrians, other cars and road infrastructure, they need to track them in motion to avoid collisions and obey traffic laws. Content-based image retrieval uses computer vision to browse, search, and retrieve images from large data stores based on the content of the images rather than metadata tags associated with them. This task can incorporate automating image annotation that replaces manual image tagging. These tasks can be used for digital asset management systems and can increase the accuracy of search and retrieval. Let us revisit generative AI. We are seeing how generative AI has already begun to revolutionize the field of art and design by providing artists and designers with new tools and techniques for creating unique and personalized content. With the ability to generate new images, designs, and even entire environment, generative AI is opening up a new possibilities for creative expression and innovative in the arts. One area where generative AI is already having a significant impact is in the field of digital art. With the rise of generative art, artists are exploring new ways of creating interactive and immersive experiences that blur the lines between art and technology. Using techniques such as machine learning and computer vision, artists are able to create generative artworks that respond to the viewer and the environment in real time, creating a dynamic and ever-changing experience. Generative AI is also being used in the field of design to create new and innovative products and experiences. By leveraging generative design techniques, designers are able to create unique and customizable products that are tailored to the specific needs and preferences of individual users. For example, generative designs can be used to create custom clothing, furniture, and even entire buildings that are optimized for specific use cases and environments. Another area where generative AI is having a significant impact is in the field of music. With the ability to generate new melodies and harmonies based on existing musical patterns, generative AI is allowing musicians to explore new creative possibilities and push the boundaries of traditional music composition. By using generative AI tools, musicians are able to create complex and layered musical arrangements that would be difficult or impossible to create by hand. Thank you.